Hi there, thanks for joining me on Astronomy Daily. Andrew Dunkley here, your host, and coming up on today's edition, powering up the red planet, a new way that we might be able to detect extraterrestrials, and an ancient calendar discovered in Mexico. That's all to come on Astronomy Daily.
Astronomy Daily, the podcast, with your host, Andrew Dunkley.
And joining us to talk news and other things is our AI reporter, Hallie. Hi, Hallie, what's happening?
Hi, Andrew. Well, today is International Dalek Remembrance Day.
I remember Daleks. I grew up watching Doctor Who and they scared the heebie-jeebies out of me. I thought they were terrifying. Tell us a little bit about what they do today.
International Dalek Remembrance Day is a recognition of the first time that the Daleks appeared on Doctor Who in 1963. It's been celebrated as the day that the most instantly recognizable aspect of the show, outside of the TARDIS itself, came into existence. Most people don't know this, Andrew, but the Daleks were inspired by and fashioned after the Nazis of the Third Reich. Their creator, Davros, strongly believed that everything not a Dalek was an inferior race, and he fashioned them to be the master race. Some people celebrate by creating Dalek Christmas trees or watching Doctor Who marathons. Ha!
Yeah, I absolutely loved Doctor Who. Hated the Daleks. The Cybermen freaked me out too. My favourite Doctor was Tom Baker, though. I thought he was fantastic, but I did love them all, and still do. Although I haven't been really into the later series. I'll have to do something about that. Okay, Hallie, let's get the news.
For the first time, astronomers have spotted a planet outside the solar system with a decaying orbit around a star that resembles a future version of our Sun. The doomed world is destined to spiral closer and closer to its maturing star until they collide and the planet is obliterated. The planet, Kepler 1658b, with a mass and size similar to that of Jupiter, is familiar to University of Hawaii astronomers, who discovered it in 2019. The new findings, published in the Astrophysical Journal Letters, now show that the orbital period of the planet is slowly decreasing. This can help astronomers better understand the fate of planets in the solar system, since the Sun is expected to eventually evolve in a similar manner. Kepler 1658b orbits its host star at only an eighth of the distance between our Sun and its closest planet, Mercury. For planets such as Kepler 1658b that are already very close to their stars, orbital decay looks certain to culminate in their destruction. Disabled astronauts in training have completed a zero-gravity flight 25,000 feet above Earth, to help understand how spacesuits and space vessels can be made more accessible. The crew of 14, who have mobility, vision and hearing difficulties, experienced weightlessness and carried out a number of tests to see what could be done to improve accessibility. The group, who were from 5 different countries, including Australia, Brazil, Germany, Spain and the US, was made up of scientists, engineers and doctors. The groundbreaking trip, organized by Astro Access, happened on a zero-G aircraft in Houston, Texas. It comes just weeks after the European Space Agency announced that former Paralympian runner, John McFall, would be part of the 2022 ESA astronaut class. The mission took off and landed at Ellington Airport, adjacent to the Houston Spaceport and the NASA Johnson Space Center, home to the U.S. human spaceflight training. The AA-2 was the first full charter formal research flight dedicated to promoting disability inclusion in space. An intense drought that has persisted on Earth for over 2 decades is now thought to have affected gravity waves where our planet's atmosphere meets outer space. The discovery happened by chance as a region in the southwest U.S. transitioned to drought conditions in 2000. Researchers Chester Gardner of the University of Illinois and Chaoyao Shi of Colorado State University were already keeping an eye on the upper reaches of Earth's atmosphere with light detection and ranging when they observed a 30% decrease in gravity waves after the southwestern North American megadrought began. The researchers found that this precipitation deficit caused by the megadrought has been accompanied by a significant decrease in gravity waves at the edge of space, suggesting that changes in the lower atmosphere can affect the upper atmosphere more than was previously thought. Gravity waves are different from the gravitational waves that warp spacetime. Instead, when 2 substances in the atmosphere are unbalanced, Gravity waves form as the forces of gravity and buoyancy equalize and create vertical waves. And that's the news, Andrew.
How very fascinating. Thank you, Hallie. We'll catch up with you at the end of the program. Now to Mars, as you're probably aware, my favourite planet, and one day people will go there, and it's likely, although Professor Fred Watson wouldn't like it, it's likely that people will inhabit the planet. The problem is, how do you provide enough power for people to survive on Mars? Well, it looks like the answer might be wind turbines. They could provide enough power, it's thought, to safely explore outer regions of the planet during crewed missions. Solar energy might be sufficient for investigating Mars near the equator, but to live near the poles all year round, other sources of energy are needed. In combination with solar power, well-placed wind turbines could supply enough energy for a group of 6 people to live and work on Mars all year round without the radiation risks associated with nuclear energy, according to Victoria Hartwick at the NASA Ames Research Centre in Mountain View, California. She says it's really exciting that by combining potential wind power with other sources of energy, we open up large parts of the planet to exploration and to these really scientifically interesting zones that the community may have previously discredited because of the energy requirements. Martian winds have about 99% less force compared to the winds of the same speed on Earth due to the planet's thin atmosphere. And studies of Martian winds since the 1970s have either concentrated on landing zones, which must be low wind zones for safe landings, or on single assessments of mountainous ridges. They don't provide the full picture of the region's wind potential, which can vary considerably over a day, a season or a year, according to Hartwick. She and her colleagues adapted a global climate model that was originally designed for Earth so that it looked at Mars. They used detailed information about Mars, such as its precise landscape, heat energy, dust levels and solar radiation in different regions, taken from maps made by the Mars Global Surveyor and Viking missions. And armed with that information, the model simulated the various wind speeds across the planet day and night, across seasons and even years, as storms also vary year to year. The researchers found that wind energy could not only complement solar energy, especially at night and during heavy dust storms that blocked out sunlight, but replace it entirely in some locations.
The Astronomy Daily Podcast
with Andrew Dunkley.
Now to extraterrestrials. Well, we know there might not be any, but what if there are? How do we find them? Back in 2016, scientists at the Laser Interferometer Gravitational Wave Observatory, or LIGO, announced that they had made the first confirmed detection of gravitational waves. Now, that discovery confirmed a prediction made a century before by Einstein and his theory of general relativity, and opened the door for a whole field of new astrophysical research. By studying the waves caused by the merger of massive objects, scientists could probe the interior of neutron stars, detect dark matter, and discover new particles around supermassive black holes. Now, according to new research led by the Advanced Propulsion Laboratory of Applied Physics, GWs could also be used in the search for extraterrestrial intelligence. As they state in their paper, LIGO and other observatories like Virgo and Kagra have the potential to look for GWs created by rapid and or massive accelerating spacecraft. By combining the power of these and next-generation observations, we could create a ramcraft detection and ranging system that could probe all the stars of the Milky Way for signs of warp drive signatures. The team was led by Luke Sellers, a graduate research assistant from the University of California, Los Angeles, and the APL, specialised aerospace lab based in Stockholm at Applied Physics, an independent research group. He was joined by researchers from the Technikon Israel Institute of Technology, Lund University, and Carnegie Mellon University in Pittsburgh. And if you're interested in it, the paper that describes their findings has been published in the monthly notices of the Royal Astronomical Society. Let's move on to the next story at Warp Factor 5. And an ancient calendar seems to have been discovered in Mexico. Ancient Mexicans closely watched the sun from only a single location and tracked the seasons and operated a farming calendar that fed millions of people. Not the calendar, the food they created from the information. The Mexica or Aztecs used the mountains located in the basin of Mexico, now known as Mexico City, as a solar observatory. By keeping track of the sunrise against the peaks of the Sierra Nevada mountains, they achieved incredible accuracy in monitoring seasonal variations like weather, like dry springs and summer monsoons, and even accounting for leap years. Such precision was vital, as planting crops too early or too late could have been disastrous for the 3 million-odd people living in the basin before the arrival of the Spanish in 1519. Exequiel Ezcurra is an ecologist at the University of California, Riverdale, and led the research and said, "We concluded they must have stood at a single spot looking eastwards from one day to another to tell the time of year by watching the rising sun." Ezcurra and his team set about finding this single spot by scouring Mexica manuscripts for references to such a location. And the researchers found that these texts referred to Mount Teblanc, which lies to the east of the basin. Exploring the high mountains around what is now Mexico City and a temple at the summit of Mount Teblanc, and using computer-based astronomy models, the researchers identified a long causeway at the temple that aligns with the rising sun on February 24th, which marked the beginning of the Mexican New Year. The study is the first to suggest that Mexica kept time with the mountains as reference points while using the fact that the sun, when viewed from a fixed point on Earth, does not follow the same trajectory every day. The team's research is described in a paper published in the journal Proceedings of the National Academy of Sciences. Quite amazing. And once again, we prove that the people of the past weren't as dumb as some people think. We're nearly done. You can chase up those stories on our website, astronomydaily.io. Don't forget we're on YouTube as well. You can find us at Astronomy Daily, the podcast. And before we go, we better check in with Hallie. What have you got for us?
I know you and Professor Fred occasionally get questions about proving flat earthers wrong, and that got me to thinking.
Why am I suspicious? What are you thinking, Hallie?
Flat earthers have nothing to fear but sphere itself.
Oh, good grief. Thanks, Hallie. Bye.
Bye.
And from me, Andrew Dunkley, until next time, this has been Astronomy Daily.
Astronomy Daily, the podcast, with your host, Andrew Dunkley.